It's ready to go whenever you are, Charles. The fourth and final exciting section.
In this part, I'm going to talk about information flow through time and then take a few minutes right at the end to try to sum up some general themes from the whole masterclass. So let's start with this picture that John showed you already, summarizing Zipf's law of abbreviation, the idea that longer words tend to be less frequent. So I think of this as something that captures a static property of language. The lexicon is as it is, and children have to learn it. And it just so happens that the longer words they're learning tend to be the less frequent ones. This idea behind Zipf's law that expected information tends to be expressed by less costly forms applies in places other than the lexicon. It's not just about words. So if you look at grammatical marking, for example, here is a table from a recent paper by Hasselmath. It has a number of grammatical distinctions here. And in each case, the element on the left is more frequent than the element on the right. So singular, more frequent than plural, present, more frequent than future. And it's also the case that the element on the left is expressed by less costly forms, by shorter forms. So singular in English is 0 marked, whereas we have the marker S for the plural. So I think of this as the same idea behind Zipf's law, just applied to grammatical markers rather than words. What I'm going to focus on in part 4 is thinking about how this Zipfian idea applies to speaker choices in context. So the words of a language and the grammatical markers and how to use them, those are relatively static things that just need to be learned by a language learner. But you can also think about choices that a speaker is making in context. So there are many times when a speaker has different options at her disposal, and we can see whether this Zipfian idea that she tends to use less costly forms in cases where the information that she wants to convey is expected, we can see whether that gives us an account of dynamic choices in context. So thinking of examples like at the level of the word, you take the Zipfian idea, but instead of just looking at the static lexicon, look at cases where there are two variants of a word, like info and information. Is it the case that the longer form of the word tends to be used when the meaning is less predictable? You can look at cases where function words and grammatical morphemes might be optional. The speakers tend to use the more explicit form and include those markers when the material is less predictable. You can look at more or less explicit anaphoric expressions, so he versus the manager versus the manager of the bank. You can look at grammatical alternations. So he gave the present to Maya. One of those is longer than the other. It has that additional to, and you can say, well, it's a longer one used when the material is less predictable. Variant forms here for adjectives, cleverer versus more clever. We can ask the same question. We can also ask the same thing about pragmatics. So differences like John stopped the car versus John caused the car to stop is a longer form used in cases where the meaning is less predictable. Okay, so I'm going to show you a few results suggesting that you can indeed apply Zipf's law in this way, and the basic predictions often are supported by the data. So here's the first result looking at word choice in context. So this is exactly the info versus information kind of example I mentioned before. So if we pick one example here, like photo. So this study looked at pairs such as photo, photograph, info, information, and looked at different sorts of contexts where those forms appeared. So if we think about photo, a low surprisal context for the concept of a photograph would be something like stand still while I take a. So after hearing that, it's pretty obvious what's going to come next. But in a sentence like I have a photo, after the I have a part, you'd still be relatively uncertain about what's going to happen next. This plot here is summarizing the result that the longer form photograph tends to be used in high surprisal contexts. So it's looking at the difference in surprisal when the long form is used versus the short form. And most of the data points here are above this line, suggesting that long form is more likely to be used in cases where the material is unexpected. So it's the same idea as zip, just looking at word choice in context. Here's a figure that summarizes some of the many choices that speakers have when they're, in context deciding whether to compress the signal they're trying to communicate. So at the top here, we have something like the default form of a sentence. They predicted that Kazakhstan would not win the World Cup. Down here, we have how that signal might actually be realized. So you can see in the realized version, words like the optional that might be dropped. We might have some contractions, would not gets turned into wouldn't. Same ideas play out the level of phonetics and morphology. So things like expected words here might be produced faster. So this idea about managing information flow by making expected things brief is something that applies across many levels of linguistic structure. The focus of this part 4 is a principle called uniform information density principle, which is a general regularity that captures how speakers are managing information flow potentially across many different linguistic levels. So I think some of the early influential work on this comes from Fenk Oxelon, and here's a quote from her. If the communication system is effective and economical, the changes in the flow of information should not be too pronounced. So the way I think about this is in terms of pictures like the one shown here. So if you think about a communication channel where we have some kind of constraint shown here as the thin black line at the top, if you wanted to convey as much information as possible, you should be doing something like we have here on the right side of the slide. At any moment, you should be conveying an amount of information that's close to the capacity of the channel, but not exceeding it. So this would be good use of the channel. Over here would be a bad use of the channel. So one thing that's bad is that there are places here where the channel capacity is being exceeded. So that's going to make it hard for the listener, presumably. But also there are cases here where we're wasting the capacity of the channel. During this part and the utterance, we're communicating fewer bits than we could. So this is the idea of UID principle, uniform information density principle. And one of the questions to ask about this is, well, if this is right, what is the capacity limit here, and how might we think about it? So I think a good place to start thinking about this is in terms of an articulatory bottleneck. So this idea comes, at least to my knowledge, this idea comes from Levinson, who talks about the fact that the transmission rate of human speech is relatively low. So roughly 7 syllables per second. And on the other hand, there's evidence that other aspects of language processing can run much faster. So for example, if you take a podcast and play at double speed, you can still understand it, suggesting that comprehension can run at a higher rate. And similarly, there's some evidence that planning utterances can run at a higher rate than 7 syllables a second. So first hypothesis is that the bottleneck here, the channel capacity might be coming from articulation. John mentioned a study earlier, which allows us to look at this. So I'm showing a figure here from the paper. I've split it into two to fit on the slide. So the x-axis here is syllables per second. Levinson's figure of about 7. That's pretty close to the mean speech rate across the different languages in this study. So this is somewhat consistent with Levinson's point, but on the other hand, there is quite a lot of variation. So languages like Thai are actually, quite far from the average speech rate of around 7. And it's interesting that the very same study also talks about information rate through time. So measured something like bits per syllable. And again, I've broken the plot in two. I think John showed this plot before. And now the interesting thing is, if you see how these different languages line up against each other, there's still some variation, but there's less variation than we saw for the speech rate plot. So this is suggesting that perhaps articulation is not the single fundamental constraint. Perhaps there's some other constraint. So I think this result here is consistent with the idea that there might be a universal constraint or bottleneck across languages, but perhaps it's not just articulation. So of course, the explanation for how the speech rate result and the conditional entropy result that I showed you can both be true is that for languages where the speech rate is high, those are the languages where less information is being conveyed per syllable. Whereas if each syllable carries a large amount of information, speakers need to slow down. So this is what John mentioned before. Okay, so if we take this study as some evidence that there might be this universal bottleneck, we can go ahead and see, do the predictions of the uniform information density account actually come through when we test the idea at these different levels of linguistic structure? So in the time we have today, I'm going to focus on two examples, syntactic reduction and syllable duration, and give just a whirlwind overview of some other places where the principle has been applied. So let's start with syntactic reduction. So I'm going to focus on cases where there is a complement clause and there's an optional complementizer. So we have examples here. The speaker could say, my boss confirmed that we were absolutely crazy. Or the speaker could say, my boss confirmed we were absolutely crazy. We are going to be thinking about the predictability of the complement clause as a function of what's come earlier in the sentence. So this little plot is trying to suggest that after hearing my boss confirmed, we is somewhat unpredictable. If we didn't have the complementizer, then we is unpredictable. The surprisal associated with that word would be high, and maybe that would put us above the capacity channel. So in the context of this particular sentence about what my boss confirmed, it might be a good idea to include the optional complementizer to keep the information rate relatively smooth over time. On the other hand, for this sentence here, after hearing my boss thinks, it's fairly predictable that I might be the next word to follow. And so in this case, the uniform information density idea would suggest that we can safely drop the complementizer. And in fact, it would actually be good to drop the complementizer, because if we included it, that would pull the surprisal down relatively low, which means we're not making good use of the channel. Okay, so this is the idea, this kind of that reduction example, for which I'll show you some data. The study we're going to look at looks at the probability that a speaker uses a full form, so includes the optional that, plotted against some measure of the predictability of the material in the complement clause. And so for this result, this predictability is cashed out in terms of bigram probabilities. How predictable, say, the we is as a function, the we in the complement clause that starts the complement clause is as a function of the two words that preceded. And you can see as the initial material in the complement clause becomes more and more predictable, speakers are less likely to use the full form. In other words, they're more likely to drop the that. So this result is just based on English, I think. And I'm actually not sure if it's been supported in other languages, as well. Okay, so we have this result supporting the prediction of the UID principle, but that doesn't really tell us about what the underlying mechanism might be. Like, why is it that speakers tend to drop the that in cases where the complement clause is predictable? So there are at least two classes of explanations that need to be considered. So the first, there's a class of explanations that, broadly speaking, are something about production. The idea here might be that if the speaker is going to generate this complement clause, which is a little bit unpredictable, then adding that is useful because it buys time for the speaker and helps her to plan the utterance, the rest of the utterance that's going to follow. The explanation could also be something to do with the listener or the recipient, something about comprehension. So this would be the idea that including that in cases where the material is unpredictable is helpful for the hearer, because it sort of spreads out the information over time, meaning that the speaker can kind of keep up and generate the intended meaning more smoothly. Okay, so I'm not going to resolve which of these two explanations is actually the right one, and perhaps it's both. Just wanted to mention that both of these explanations are important to consider. It's also important to consider how this uniform information density might relate to other theoretical accounts of syntactic reduction in the literature. And this is a paper, a table from a paper by Jaeger, I believe, and he tests a large number of other predictors of that reduction coming from the previous literature. So I'm not going to talk about all of them, I'll just mention one of them. Previously, some people have suggested that the distance between the main verb in a sentence and the complement clause is a predictor of whether or not that gets included. So roughly speaking, if the distance between the main verb and the clause is high, then maybe the sentence is a little bit harder to deal with, and so speakers more likely to include the that. So they run a big regression. They include a predictor for dependency length, the distance between the matrix verb and the complement clause, and suggest that there is an effective uniform information density even when you control for this other predictor and for a large set of other predictors that they had as well. Okay, so
is this, Charles, there's a couple of interesting questions about the speech rate thing. Is this a good point for?
Oh yeah, this is a good point. Sorry, I missed that in the chat, okay. So let me see.
So firstly, Alex asked for that, how do they measure the amount of information in the language samples? Does it depend on context, what is already known, what is relevant, etc.?
So you can correct me if I'm wrong, John. I think it's purely about the predictability at the syllable level, looking at just a single, is it one syllable or two of context? So it's a very simple measure, and arguably taking more of the context into account would be ideal.
Yeah, I can't remember exactly, but I think they have one study where it's like that based on a contextual phonological entropy. And then there's another study where they actually used like parallel corpora of the same text in different languages and had some assumption about all the languages expressing the same amount of information, but I can't remember. I think I guess that's not this study, is it?
Yeah, I mean, there's an important general question here, which is which way of measuring predictability sort of best aligns with what people are doing. And so just computing predictability in terms of pairs of syllables or trios of triplets of syllables, that's probably not going to be accurate.
Then the other one is, so Alison asked, has there been any research into how the speech of neurodivergent individuals differs from patterns at the population level for information theory principles? Do you know, Charles?
I'm not aware of that. The closest thing I know is research into how speakers manage things like information flow as a function of who they're speaking to. So does a speaker say slow down the information rate turning to somebody when talking to somebody who's not a native speaker of the language, or maybe a child as opposed to an adult? And so that's I mean, separate from Alison's question, but I guess related to the question about like how variable are these things across different populations of speakers and listeners.
And Alison also raises the point about, which she says, feeling uncomfortable about the idea of optimality, which I think is a worthwhile point, because also apart from neurodivergent individuals, there's also the possibility that, perhaps according to some of these measures, different languages might come out as being less optimal in some way. And yeah, it's the term does feel very loaded.
Yeah, so I mean, to me, I'm not sure why it would be a problem so I guess if something is not optimal, that doesn't mean it's not functional and not useful. And, you can have a communication system that does the job perfectly well, but is not theoretically optimal. So I guess there's a question of whether you take, whether you think of optimal as being normative in some way or not. And at least there's one reading of it where it's optimal. It's kind of just a neutral thing, sort of where the measuring stick is in terms of information theory, and whether or not a language is close to that doesn't matter. Like you can't, it's not a matter of being better or worse. It's just kind of a neutral measuring stick. But I realize the label optimal does, you know, connote a lot of other things as well. Okay, so let me talk a little about syllable duration now, which is the second example. And so here the idea is we're going to look at how long it takes speakers to utter syllables or words, and whether that varies as a function of how predictable the syllable or the word is. And so as an initial example, if you think of comparing these two sentences here, paid jobs degrade the mind, mummy, you've been on my mind. The idea here is that after paid jobs degrade, it's not all that predictable that mind is going to come. And so the idea is that speakers might take a bit longer to utter that word. Whereas in a more predictable context, speakers can safely compress the signal here and generate the word a little bit quicker. Okay, so uniform information density is sort of a more recent label, but back in 2004, Aylett and Turk had a paper, influential paper on what they called the smooth signal redundancy hypothesis, which is really getting at the same idea behind the uniform information density idea. So we'll show you some of the results that they included in the paper here on the smooth signal redundancy hypothesis. Here they are measuring predictability in three ways and plotting syllabic duration against those measures of predictability. So first is probabilities at the level of trigrams, so triples of syllables. Second, looking at words and looking at word frequency. So the idea being that more frequent words ought to be uttered faster because they're more expected. And then this third panel on the right here is about reference mentions. So if you look at the number of times a particular element in the discourse is mentioned, does it tend to be, does the label for that element get uttered faster later on in the discourse after it's come up many times before and after it's presumably quite familiar? And in all cases, they find this decaying relationship between duration and probability, confirming that material tends to get generated faster when it's expected, and that holds across all of these three different ways of measuring the predictability of the information. Okay, as before, there are these two classes of explanations about why the finding might be there. So first, something to do with production. Maybe it's the case that predictability helps the speaker select and articulate the word. So in a sense, the speaker's already prepared for the material that's predictable. Could also be the explanation having to do with comprehension. So predictable forms are easier for the hearer to process. And so the speaker is kind of sensitive to the needs of the listener when generating the utterance. Okay, so those were the two examples I wanted to mention in most detail. Let me quickly mention a couple of other places where the uniform information density idea has been applied. So for referring expressions, you have a choice about whether you refer to, say, a person in the discourse using a pronoun or a noun phrase. And there's evidence in this work from Tiley and Piantadosi that the longer form, noun phrase forms tend to be used when the referent is less expected. So consistent with the UID idea. And John pointed me to this line of work that's interesting to me, but I'm still learning about it, suggesting that same idea occurs even if you're thinking about predictability, not just in terms of the preceding linguistic context, but sort of the social context, like the set of individuals between whom the dialogue is occurring. So in societies of intimates, which might be groups of smaller communities where people are more likely to know everybody else, then the context is established, the reference will typically be more predictable, and so more compact expressions can be used. And this literature John pointed me to, I think, suggests that there's some evidence supporting this idea. Okay, jumping up from phrases to the level of the whole discourse, there's some suggestive evidence that the uniform information density principle might apply there as well. And so this relates to, I guess, John's comment there in the chat about discourse givenness. So I picked a random article yesterday, and here is the first, at the top here is the first sentence from the article, and the bottom here is, I think it was the sentence that begins paragraph 3 or paragraph 4. And you can see that the sentence here from paragraph 3 is longer. And so there might be this general kind of pattern where sentences at the start of a discourse are simpler, and later on you have more complicated kinds of sentences. And Genzel and Charniak provide some initial evidence for this in a study where they measured the predictability of an entire sentence in 2 ways. So first, an n-gram model did something like chop the sentence into triples and just multiply the probabilities of all those triples together. And they also computed predictability using a language model. I think it was something like a probabilistic context-free grammar, something like that. So 2 measures of the predictability of a sentence. And their finding was that as you move on in a discourse, the predictability of the sentences increases. So when you look at this first, you might think, well, this is inconsistent with the uniform information density idea. I would have expected the entropy to be constant. After all, information density is meant to be a constant over time. But Genzel and Charniak argued that these really simple models are computing entropy only at the level of a sentence. They're not taking the full earlier context into account. And if you do that, by the time you get to sentence 20 in a discourse, a hearer, the human reader, is going to have all of the context established by the preceding sentences. So if you're computing entropy just at the level of individual sentences, the estimates you get are going to be overestimates of the true entropy. And so in fact, this increasing pattern is exactly what you'd expect if the true entropy of the sentences were actually constant over time. So some evidence here that UID applies even at the level of discourse. Couple of other very quick examples. UID has been applied to the use of contractions. So I am versus I'm. And again, some evidence supporting the UID idea. Longer form tends to be used when it's less predictable. It's been applied to the use of discourse connectives, so things like however and indeed. And again, the finding suggests that those connectives tend to be included when material is less predictable. And finally, connecting a bit with what John was saying at the end of part 3, there's been some work on uniform information density and word order. And let me show you just a couple of figures from this paper by Moritz and colleagues. So they were computing information contributed by each element in a little triple, subject, verb, object triple, where those elements appear in some order. They found the most uniform information occurred for SVO, which I believe is the most common word order across languages. For orders where the object comes first, which are much, much rarer, they found the greatest departures from uniform rate of information transfer over time. So I think putting all of these studies together, there's at least some suggestion that the idea of uniform information density might apply across lots of different levels. Okay, here's what I see as some of the important questions here. We already talked about the question of what the underlying explanation is for these phenomena. We already touched on the question of what's the best way to compute the probabilities required by a UID model, where by best I mean the way that lines up with, you know, the best account of the information people are actually using when they're forming expectations, say, about what's going to come next in a communicative exchange of some kind. Finally, if it is the case that UID applies at all of these different levels of linguistic structure, then it seems like there's an interesting, challenging problem the speaker has to solve. So if there's the option of reducing the signal at all of these different levels. How do speakers manage information flow at all of these levels? How do they decide which levels to prioritize in which contexts? And as far as I know, there's no work that looks at that in very much detail. Okay, so before getting into the general sum up, here are some take-home messages from part 4. So first of all, the Zipfian idea that expected material tends to be expressed in a way that's relatively brief. That can account not only for static properties of language, but also for speaker choices in context. And when we start to look at speaker choices in context, there's a body of literature from a bunch of different levels of linguistic structure suggesting that speakers manage information flow to keep the rate of information transfer roughly constant. Okay, so for this part on UID in particular, these are the 2 papers that I recommend looking at, particularly this first one, which gives a really great overview of applications of this principle to a number of different areas. Okay, so leaving part 4 aside, let me now turn to some general final thoughts about information theory and why John and I were excited to have the chance to think about putting together this masterclass. So first, let's think about contributions of information theory. So the contribution that I think we've emphasized most is that information theory gives you a way to characterize communicative efficiency, and this is useful for developing functional explanations of language. It allows you to say, well, that aspect of language looks the way it does because that's what language needs to be like in order to achieve efficient communication. There are other ways, though, in which information theory can be used. So it gives you a tool or a measuring stick for quantifying predictive relationships between elements of language. And as 2 examples of this, there's recent work looking at the question of systematicity. So how predictable is meaning given form, and things like gender systems. How much information does a definite article in German convey about the identity of the following noun? So both of those are cases where information theory is useful because you can start to put numbers to measure these sorts of things. And that's useful. It's kind of independent of any claims that you might want to make about communicative efficiency. Okay, so if we come back to this first contribution, which is the one that, to me, of the 2, it's the one that's most fundamental and most valuable. Sometimes when I talk to people about information theory or I read discussions of this in the literature, there's sort of the feeling that, isn't it kind of obvious that language supports efficient communication? You know, that's what it's for many people, but not everybody. That's what language is for. So maybe it's not surprising that language supports efficient communication. The way I think about it, it is somewhat surprising to see languages getting close to being efficient in this sense, because there are a lot of reasons why language might depart from efficiency. So here are some of them, most of them taken from paper by Levshina. So systemic pressure might mean that there are local departures from efficiency. So if you think about singular versus plural, well, most of the time, singular is encountered more often than plurals, which means it makes sense for the plural form to be a bit longer. But in cases like in English, P versus Ps, well, actually the plural form is more common. So this is a case where there's a local inefficiency coming from analogy, and that could be related to ease of learning, which is element 3 here on the list. So you might have systems that would be really efficient, but are just not plausible because they could never be learned by a child. Okay, there are cognitive processes like persistence. So in a dialogue between 2 people, once the context is established, it makes sense to use briefer names and briefer labels for the reference. And we talked about some evidence for that. But there's also some evidence for persistence. So speakers might continue using the label that had already been established in the prior context just because it's available in their minds. And so this would be a case where you see departures from efficiency. Phonological factors sometimes work against efficiency. So avoidance of stress clash is one example. If you look at this sentence here, one of the best ways to do it is to break bread with them. The 2 here is optional, And so this might be a case where optional material is actually included, making the overall sentence longer and less efficient, just to avoid having like too many strong syllables right next to each other. There could be social considerations. So there might be very efficient ways of saying things that are not used because they're direct and impolite. There could also be normative considerations. So sometimes, people are not inclined to speak in a way that's as efficient as possible because they think that others will consider them ungrammatical, or they're worried that others might think that they're going to be using the language wrongly. And finally, John mentioned to me this idea of extravagance, the idea that sometimes speakers seem to have a motive to make their speech interesting and novel, which runs directly opposite to the idea of maximizing efficiency. Okay, so I suppose the first thing to say about the isn't it obvious point is that, well, in my mind, it's not obvious. And the second thing to say is that the real goal, I think, is not to say yes or no, this given aspect of language is efficient or it's not efficient. The real goal is to explain the linguistic phenomena that all of us are interested in. And so if we go back to color naming for a minute, to me, the exciting result there is not that the languages cluster near the optimal frontier on the plot. It's that if you look at individual languages, it feels like the information theoretic account is giving you some account of where the boundaries between color categories lie in individual languages like Agarabi. And so here are a couple of pictures that sort of summarize how I think of information theory. If you think of any theory, it's something that lets you start with a set of assumptions and make predictions and develop explanations that let you try to account for the things that you might be interested in. Information theory is a very relatively general set of ideas. So we have relatively small amount of stuff here on the assumptions side. But on the other hand, I hope the material that we've talked about today in the masterclass suggests that there's potentially quite a large set of things that the information theoretic approach is able to explain. So this, in my mind, is a good theory. You put in a little bit and you get out quite a lot on the other side. A couple of final general pointers about where to look if you'd like to learn more about this. So in addition to the references we've already included, there are 3 fairly recent courses on information theory. Well, this one's a decade old now. And I mentioned these because in each case, you can find the syllabus online, and each of those, in each case, the syllabus has a large number of readings and interesting pointers to the literature. So I suppose we have a couple of minutes before 12:30. John, can we open it up to sort of
Absolutely, let's.
Questions people have here.
Yeah, and we already have an interesting point Alice raises in the chat about interpredictability, UID, and semantic interpretation. Do you want to speak about that, Alice? Or?
Oh, I'm happy to. I was just musing into the void. Really, I didn't expect a response.
You say the last part of it says wouldn't be very informative otherwise. I guess I don't quite follow that part.
Well, I guess I'm just thinking about, if you have adjectives, scalar adjectives like large and small that are interpreted as, you might expect them to be completely neutrally or with a kind of absolute value that large is large regardless of the noun it modifies. It would be much less informative than how they're actually used. So if you're saying a large elephant, well, all elephants are large, you're not actually getting any valuable information from that. So yeah.
Yeah, right. I see, which could tie in with something to do with like the contextual predictability. I think I've used up too many of my brain cells for this morning to fully follow this through, but it definitely sounds like you could be onto something there.
So Alex, has a point there about pragmatics and relevance. And so I suppose Gricean ideas, that's one place where there have been some information theoretic approaches. And so I suppose there's some work by Noah Goodman and collaborators and Mike Frank recently that people who are interested in this might be interested in. Okay, so John, seeing as it's 12:30, shall we break as a group